Good morning, students. Today we will start with the fourth chapter of physics, and that is pressure in fluids and atmospheric pressure. We first begin with the topic pressure in fluids. Now, under this topic, we should know a few terms. The first one is thrust. Now, thrust is basically a force acting normally on a surface. What is the difference between thrust and force? Actually, force can be applied in any direction. But you can see that I have drawn a diagram over here to depict thrust. Here you can see that when a force is applied perpendicular to the surface, making an angle 90, this force is known as thrust. And we say that thrust exerted by a body on a surface is basically equal to the weight of the body acting on that particular surface. Because the force is in downward direction and perpendicular, so we say that thrust is a vector quantity. Now let us look at the units of thrust. The SI unit of thrust is Newton and the CGS unit of thrust is Dyne. The next thing which we are going to do is we are going to see that how is the SI unit of thrust related to the CGS unit of thrust. For that I am using the formula, as I told you that thrust is equal to the weight of the body. So I am using formula M into G, where M stands for the mass of the body and G stands for acceleration due to gravity. Now 1 Newton is equal to 1 mass is in kg and the G is in meter per second square. So 1 Newton is 1 kg into 1 meter per second square. This is the breakup of 1 Newton. Now let me convert kg to grams. So 1 kg is 1000 grams and 1 meter per second square is 100 centimeter per second square. Therefore I get 1 Newton is equal to 10 to power 5. Now I combine this gram centimeter per second square. What is gram centimeter per second square? It is equal to Dyne. So therefore this is the relation between the SI and CGS unit, that is 1 Newton is equal to 10 to the power 5 Dyne. There are two more units of thrust and they are known as the gravitational units of thrust. The gravitational SI unit of thrust is kgf, which is called kilogram force, and the CGS gravitational unit of thrust is gf, that is called gram force. What is the relation between the two? Let us look at it. 1 kgf is equal to 1000 gf. And now let us look at the interrelation. Let us look at the interrelation of between kgf and Newton. Okay, so 1 kgf, let us break it up, is 1 kg into the value of g, which is 9.8 meters per second square. When I multiply this, I get 1 kgf is equal to 9.8 kg meter per second square. And children, what you already know that kg meter per second square is nothing but it is Newton. So instead of kg meter per second square, I put Newton. So therefore I get 1 kgf is equal to 9.8 newtons. Now let us look at the interrelation between gf and Dyne. 1 gf is equal to 1 gram into the value of g now in centimeter per second square is 980 centimeter per second square. When I multiply, I get 1 gf, that is 1 gram force, is equal to 980 gram centimeter per second square. And what is gram centimeter per second square? Gram centimeter per second square, as seen earlier, is equal to Dyne. So we get 1 gram force is equal to 980 dynes. So after this topic of thrust, we go to the next topic, and that is pressure. Now, what is pressure? Pressure is the thrust exerted per unit area of surface. The pressure is given by the formula thrust upon area. And let me tell you that pressure is not a vector quantity, it is a scalar quantity because it is not only dependent on thrust but also area. So overall, pressure is a scalar quantity. Now let us look at the units of pressure. The SI unit of pressure is, let us use the formula for pressure. As I told you, it is thrust upon area. The unit of thrust we have already seen was Newton and the unit of area is meter square. So the SI unit of pressure is Newton per meter square, or it can also be called as Pascal, which is denoted by capital P and A small. Okay, now let us define 1 Pascal. 1 Pascal, if you want to define, there's no need to mug up. First, you use the formula for pressure, that is thrust upon area. And we know it is equal to Newton per meter square or Pascal. How to define Pascal? We will look at this and this simultaneous. We will say that pressure is said to be 1 Pascal when a thrust of 1 Newton acts on an area of 1 square meter. I repeat, pressure is said to be 1 Pascal when a thrust of 1 Newton acts on an area of 1 square meter. What is the CGS unit of pressure? The CGS unit of pressure is Dyne per square centimeter. The SI unit was Newton per square meter and the CGS unit is Dyne per square centimeter. Now let us look at what is the relation between the SI and the CGS unit of pressure. I first use 1 Newton per meter square. Let us look at what is 1 Newton equal to. We already know that 1 Newton is 10 to the power 5 Dyne upon what is 1 meter per second square. It is equal to 100 into 100 centimeter square because we know that 1 meter is 100 centimeters. Now let us combine. We get 10 to the power 5 Dyne upon 10 to the power 4 centimeter square centimeter. 5 gets cancelled with 4 and we are only left with 10. So we get 1 Newton per meter square is equal to 10 Dyne per square centimeter. Or it could also be called as 1 Dyne per square centimeter is equal to, let us take the 10 that side, becomes 0.1 Newton per square meter. So now here we have covered two topics. One is thrust and other is pressure. There are some other units of pressure also, but they are not very frequently used. I have made a list of units for you: bar, millibar, atmosphere and torr. Whenever we have to measure atmospheric pressure, what is atmospheric pressure? It is the pressure which is exerted by air on us. So atmospheric pressure is generally measured in terms of height of mercury column in the barometer. And normal atmospheric pressure has a fixed value. It is equal to 76 centimeters of mercury, which is also equal to 0.76 meters of mercury, or it could be 760 mm of mercury. Okay, so all these are same values, only I have done the conversion from centimeter to meter and from centimeter to millimeter. So I say that 1 atmosphere is equal to 0.76 meters of mercury, and you have to learn this value, which is equal to 1.013 into 10 to the power 5 pascals. So you should know that 1 atmosphere is equal to how many pascal? 1 atmosphere is equal to 1.013 into 10 to the power 5 pascal. Similarly, let us look at this. 1 torr is equal to 1 mm of mercury and 1 atmosphere is 760 torr. So these are the other units of pressure. Okay, now pressure depends on two things. According to the formula for pressure, as I told you, was thrust upon area. Now if I look at this formula, then I come to know that pressure is directly proportional to thrust and pressure is inversely proportional to area. Now in order to demonstrate that pressure is inversely proportional to area, let us look at this activity. I'll show this activity to you children. This is a potato and I have taken a nail. Now if you look at this nail, it has got a pointed end and it has got a blunt end. Here the area is very small while here the area is big. Let us see, when I apply pressure on this and I keep the pointed end towards the potato, you can see that when I apply pressure, it easily pierces into the potato and you can see that it is very easy to pierce it. But when I use the other end where the area is big and I apply the same amount of pressure on the nail, you can see that it is not able to pierce through the potato. So what does this prove to you? This proves to you that if the area is small, the pressure is more. And this is the reason why when you use cutting tools like this knife, you can see it has got a very sharp edge. The same reason applies here also, that when the area is small, you can see the area is small, the pressure is more, exerted by it is more, and it is easier to cut different things with it like vegetables, fruits, etc. Okay, thank you. Now as we studied thrust and pressure, we should know that pressure is not only exerted by solids, but it could also be exerted by liquids and gases. Now we first look at pressure in fluids. We should know what is a fluid. Fluid is a substance which can flow. Now fluids exert pressure which is also equal to their weight. Fluids contained, if we take a fluid in a vessel, it will exert pressure in all the directions at all the points. Okay. Now let us look at the factors on which the pressure in fluids depend. But before that, we should know the formula for pressure in fluids. The formula for pressure in fluids is equal to H rho G. This thing which looks like a curved P is actually rho. Okay, it is a symbol for density of the liquid. Now let us look at what does H, rho and G stand for. H stands for the depth of the point below the free surface. That is, the greater the depth of the point on which the pressure is acting from the free surface, the greater will be the pressure exerted. It also depends upon rho. That is, it is directly proportional to the density of the liquid. And it also depends on G, that is acceleration due to gravity. Actually, we know that acceleration due to gravity is not much, does not vary much. So basically, if you go to see, it depends on two factors. It depends upon the depth of the point below the free surface of the liquid, and it depends upon the density of the liquid. So there are two factors on which the pressure in a liquid depends. One is directly proportional to H and the other directly proportional to rho. For this, I will show you a small demonstration. Here's a demo. I have taken a bottle, plastic bottle, and I have filled it with water till here. And I have made two holes in the bottle which I have actually covered with the tape, cello tape, so that the water doesn't come out. Okay, now we have to prove here that the liquid pressure is directly proportional to the depth. And you can see this is the free surface, and this first hole is at a smaller depth while the second hole is at a greater depth. Now see, I'm going to remove the first tape and put my thumb, and I'm going to, you have to observe that as soon as the second tape opens and when the water comes out, see where the water goes up to a greater distance. I'm opening the second tape also, and now observe here. You can see that the water flows from the last hole up to a greater distance, because the liquid pressure exerted on the second hole is greater than the liquid pressure exerted on the first hole. This proves that greater the depth of the liquid from the free surface, the greater is the liquid pressure exerted by it.